All right, on question 12, what part of this equation am I looking at to make a decision on whether it's exponential growth or decay? It's the 3, right? And so since we have a 3 for our growth factor B, what do we decide? Is that growth or decay? That is definitely growth because it is larger than 1. All right, so what's so important? Yes, question. All right, so what's so important about the 5? It is the y-intercept. Now, we're going to change this question into a story problem. We're going to start with $5. You're going to need your calculator or a computer because we're going to figure something out with our calculators here in a minute. Now, can you tell me, you'll need something better than that. If you want this one, you can use this one. Yeah, that thing is not going to help you. Well, it would take a long time. Let's just say if you what percentage increase is this? What percentage increase is this? The most common wrong answer to that question is 300%. Well, it doesn't say 1.03. It says, so are you saying 1.03%? Okay, well, we already know that the B value is 3. So if every percentage starts out at 100 and we have gone up to 300, what did we add? We added 200%. If you went from 100 to 300, then we added 200%. Okay, so that's one question. Now, next question or next thought that you should consider. If you could triple your money, would you be happy? Now, if you could triple your money more than one time in a row, you could triple it 1 year and then the next year and the next year, would you be really happy? It's pretty unrealistic to think that you could do that, but if you could, sure you'd be happy. So my question to you is, how long will it take you to turn that $5 into $1 million? Take your calculator right now. You need to use your calculator or computer, and you need to start guessing. Guessing instead of looking at that, you need to be taking notes. Come on, somewhere, paper. Use your calculator, even if you're using your phone. This? No. I just divided. No. You need to pick a number and throw it in there and see if you can come up with. Bond, you got a guess for me? Are you typing on your calculator yet or computer? You're gonna have to use. I need to figure out when we're gonna have $1 million. So I like your idea of dividing by 5. Well, I'm gonna try to simplify how much we do with lugs. Okay, so you picked some numbers, you threw them in. Any thoughts on how many years it'll take me to take $5 and turn it into $1 million? You guys got any kind of guesses? Have you tried any numbers? Looked at any values?
I put 11.2 and you get your first million.
11.2. Did you guys get around 11.2? Or at least, if you tried and got close to 11 to 12 million or 11 to 12 years?
I put 11. It was like real close.
Yeah.
12. It was too much. 2 mil.
Okay, so Took about 11.2 or something like that to reach $1 million. Okay, how many years would it take you to reach your first billion? Your first $1 billion.
In 1 year?
No, not in 1 year. I'm talking about successive years. You got your original $5. We're tripling it every single year. So how many years is it going to take me to turn that $5 into my first $1 billion? It took me 11.2 years to reach 1 million. How long will it take me to reach 1 billion? Just try picking a number. Pick a number, throw it in. 17. Is your calculator working? On your phone, or are you using it on your computer? Are you using your calculator on your phone or your computer? Okay. It looked like it was just on music. You'll have to unlock it to be able to turn it to the side and get to your y to the x feature. 17.4. All right. We just figured out to reach your first $1 billion, it would be approximately 17.4 years. Folks, when you're tripling your money, it doesn't take that long for it to grow rather large. You do need a calculator for this. Okay? They just guessed. Because they didn't know what else to do. They just sat there. They told me what to put in the box. They just guessed until they got something close. Now, folks, if they put 11.2 in here, I'm going to guess they didn't get $1 million right on the nose. 17.4, I'm pretty sure they didn't get 1 billion right on the nose. They got something close. We would find a more accurate value, and we will eventually. What? Well, interest does, but finding something that would triple my money every year does not. Now, I need you to pay attention to this. This is probably one of the most interesting things that'll ever happen in your life if you're actually going to invest money in your lifetime. If you pay attention to this example, what I want you to understand is that time is your best friend. Not money. Time is your best friend. If you start earlier in life investing, you will have a lot more money when you get to retirement. If you try to wait to start investing for retirement until later in life, you will have a very hard time catching up. Very hard. Time is your best friend. If you pick up one thing from this entire course for the year, I would want you to do this. Invest your money earlier as opposed to later. I started when I got my first job at 23, but I would even suggest if you can, try to do something, earlier in life. When you're 18, if you've got, even a couple $1,000s sitting around and you're not really sure what to do with it, it's not a bad idea if you can afford not to do something with it, to invest it. And then don't touch it. Watch what happens. It'll benefit you in the long run immensely. I really hope for all of you that it would go up. All right, next on my list, I need to fill in this table. So we have y equals 2 to the x power. We do have the x values. Now, can you tell me what number is sitting right in front of the 2? That is a 1. Where would that go in my chart? Where we have the y-intercept. You guys told me that was the y-intercept. So plug in the other numbers and tell me what you get. Plug in the other numbers and tell me what you get. Yes. So you would type in 2, then you use the y to the x button, then you tell it what x button it wants. 2 squared 2, then the y to the x button. So 2 squared would be the far right box. 2 squared is. You should be able to fill in that chart. At least the 2 on the right pretty easily. Something on your own. Think. Not just copy. Think. Good. But 2 squared. You know what 2 squared is. Yeah. So that's all it's asking you to do is take 2 and plug it in there for x. 4. Nice. So 4 goes in the box. See, you do all this stuff. What's the other one? What's on the negative 2? The negative 1 side. No, the negative 1 exponent causes the fraction to flip over. It will not be a negative. What do you get when you take 2 and you flip it over? 1/2. That's right. If you plug in the negative 1, folks, you don't get a negative number, you get 1/2. What do you get when you plug in negative 2? 0.25 or 1/4. Obviously, when you plug in a 1 and a 2, you get those 2 values. If you want your money to grow, do you think it's the red graph or the blue one? Do you think it's the red graph or the blue one if you want your money to get bigger and bigger and bigger? The red one, right? Not that one. 2 of the answer choices are extremely wrong. Which 2 don't make any sense at all? C and A. Because they're growing, but they're growing at a slower rate. If I'm doubling my money, it's going to be getting quicker. It's going to be growing quickly. Now, we have the coordinate 2, 4 in our graph. Is this the coordinate 2, 4? No, that's 2, 2, isn't it? 2, 4 is right there. Make your next table. Question 14. Make your next table. What's the y-intercept? 1. If I plug in a 1, I get 1/3. But if I plug in a 2, what do I get? 1/9. As decimals, they are 0.3 repeating and 0.1 repeating if you need decimals. What happens if you plug in a negative 1? What does that do to the base? It flips it, right? And makes it a 3. What happens if you plug in a negative 2? 9. It flips it and squares it, which makes it 9. Okay? Is this exponential growth or decay? This is definitely decay. This is not what I want my money doing. Exponential decay. If you take the number, let's say we take this number 1/9, or if we keep going on and on and on and on and on, remember, every time I'm moving to the right 1 unit, I'm dividing by 3, dividing by 3, dividing by 3, and so on. Will this number ever get to 0? No, it will not. It'll be a stinking small positive number, but it will not be 0. Which means it will also never be negative. So if you're thinking about the graph, what is this thing never, ever, 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 ever going to do? It's never going to touch the x-axis, which means it's definitely not going to do this. When you look at your answer choices, which two can you obviously get rid of? B and D. They cross the x-axis, folks. We will never get a negative number. So, C and A are the only two that make any sense. It is choice C. 0, 1. There is a 0, 1. Oh, well, no. 0, 1 is right there. But I looked at like negative 2, comma 9. And this is definitely not negative 2, comma 9. Give me an example of something in this list that doesn't make any sense for the graph. D does not make any sense. C does not make any sense. A does not make any sense. It's exponential growth. There's no way it could be anything but that. They didn't even give me any options. Okay, so we asked about question 1, which we skipped yesterday.
I was like, why is there so many pages?
Yes, it does. All right, now, I want to look at this expression right here because I'm going to write it a little bit differently. I'm going to put parentheses here and here. What is 2 times 2 times 2 times 2? I got to vote for 16. Is that true? Yes, it is. So we have y equals 16 to the x. Is this what you want your money to do or not? Yeah. Holy cow, yes. If I was multiplying my money by 16 every single year, woo! That means I'm getting a private island in a short amount of time, folks. Any of these graphs look absolutely ridiculous for this? C. B, right? No linear function here. And A, nope, we're definitely not talking an upside down decay function. The only one that makes any sense in the world is that one right there. Choice D. Oh, that was number 1. Number 1 on the... if you looked closer, you would see that it's 2 to the 4x. Did it print really funny? Oh. Wow, it totally printed it. It printed a linear function. Did somebody else's print differently than that?
Mine did.
It says 24x?
Yeah. Well, the 4 is smaller. The 4 is a little smaller. It probably just got shifted down.
Yeah, it probably did. That's kind of weird. That is kind of weird. It's supposed to look like an exponent.
I thought you were going to wear that tomorrow. Oh, the heat one? Yeah. I forgot.
$2,000 in a savings account that pays interest at an annual rate of 6%. Number 1, folks, there's no savings account in the world that's paying 6% interest. Okay? Banks just do not pay that kind of interest out. Now they are more secure, they are less risk, but there's no way that a savings account is going to give you 6% interest. You're looking to get 0.5% interest. Most of it's like 0.25%. If you are raising something by 6%, so we start at 100% and we go up by 6%, what interest is that? That's 106%, which is what B value? There you go. That's what you were talking about earlier. So we know what we should put in here, 1.06. What should go here? 2,000, right? That's the starting amount. Remember, in the story problem situations, that A value is the starting amount. Now, they say things like, well, how much money will be in there after 3 years? How much will be in after 16 years? I know you're more than capable of doing that because you can plug in values.